It's just... So we are going to start section 5 today, 5.1. We're not going to get all the way through this. I have this designed to be a 3-day lesson, maybe more, we'll see, depending on what happens. But we're starting to talk about areas and distances. Now, if I gave you like some kind of curve and asked you to find the area between this curve, like from A to B, the area between the x-axis and that curve, how could you do that? How could we calculate that area? Do we have a way? You know, if it's a circle or a rectangle or triangle or those types of things, we have formulas for it. But do we have a formula for just any random curve that I might draw? No. Now we could, you know, break it into shapes and work that way. I could say, well, this is a rectangle, and maybe I can make a triangle, and you know, you could separate it into shapes and then find all those areas and add them together. But even then, would it be perfect? No. We can use rectangles to help us. We could start drawing, you know, little rectangles and finding the areas of all these rectangles. Now, will this be perfect? No. Will it get us some kind of approximation? Yes. If you wanted your approximation to be better, what should I do with my rectangles? Make them closer together, right? The more rectangles I break it into, the better my approximation would be. So that is actually what we are going to be doing today. We're going to be using these rectangles to estimate the area. And the more rectangles you use, the more accurate you would be. But obviously, you know, for time-wise, you probably don't want to do 100 rectangles every single time. You know, you have to kind of balance the accuracy with the feasibility of doing that. So we are going to just look at a couple basic examples to start us out. We are going to do both over and under estimates. And I'm going to draw a picture to help us illustrate this. I want the area of the region under f of x equals x squared on the interval 0 to 3. Okay, so x squared, if I'm just drawing a really rough graph, it looks like this, right? If you're starting at 0 and ending at 3, something like that. The first thing I want you to do is use 5 rectangles. So I'm going to break this up into 5 pieces. Now I don't just want like 5 different size rectangles, so they would be ideally 5 equal rectangles. I'm just going to kind of fix my picture so it comes out evenly. When I talk about an over versus an under estimate, you have 2 different ways to draw these rectangles. I could draw the rectangle using this point on the left. So if I start here and draw my rectangle going over, start here, rectangle going over. Would this one be an over or an underestimate? Under. All my rectangles fall below my curve that way, so those are an underestimate. This would also, sometimes it's going to be called a left-hand sum because I used the y value at the left point for each rectangle to do that. We could also look at the right-hand sum. If I use the right-hand endpoint of each one to draw my rectangle. Would this be an over or an underestimate? Over, because that time they've all fell above. Now, it will depend on the curve whether the left one is an over or under, because if it were, you know, decreasing or things, that could change. But you'll know, if you calculate both of them, one's going to be bigger than the other. Your bigger one's your overestimate, your smaller one is the underestimate, and the true answer is somewhere in the middle. So we are going to do this. We know how to find the area of a rectangle, just length times width. All of these rectangles should have the same width. How far was it from our starting point to our ending point? 3. We started at 0 and ended at 3. So my change in x is going to be, the total width was 3, and I divided it by how many rectangles? 5. So 3/5, that's the width of each of these rectangles. Okay, so to calculate my area, we have to add up the length times width for each of these things 5 times. Okay? So for my overestimate with 5 rectangles, with the over, the first point we used was right here. How would I find the y value at that point? What's my x right there? 1/5, right? Because we're going up, oh, sorry, not 1/5, 3/5. We're counting by 3/5 each time. So this would be like 3/5, 6/5, 9/5, 12/5, 13/5, or 15/5 is 3. To find the y, you just plug your x into your equation. So I'm going to add up these 5 areas. Now can we agree that since I'm going to be taking each of these times 3/5 because that's the width, could I just put the 3/5 once out in front? So I'm going to put the 3/5 here, that's the width, and then I basically just have to add up my height at each of these. So if I'm doing the overestimate, I'm doing the blues here. This first one started at 3/5, so if you plugged it into your equation, that would be 3/5 squared to get your y. And you could go ahead and square it. A lot of times it's just easier to put it in the calculator later on, especially if you're getting ugly things. Could I change this to decimal? I would just rather write 0.6 squared instead of 3/5 squared. Does that bother anybody? Okay, so my y value there will just be 0.6 squared. And we should have 5 of these because we're doing 5 rectangles. So the next one, if I add 0.6, that's at 1.2. So it would be 1.2 squared. Next one, we're just adding the change in x, which is 3/5 or 0.6 each time. So 1.2 plus 0.6 is 1.8 squared. Plus 0.6 is 2.4 squared. Plus 0.6 is 3 squared. So then I am going to put this into my calculator. And I got 11.88 for my overestimate. Questions there? For my underestimate with 5. The difference here is now I'm using those orange rectangles. What's going to change is your starting and ending point. This time the first x that I plug in will be 0. And the last one will be my 12/5 or the 2.4. So if I do that, we still have the width is 3/5. So it'll be 0 squared, and then you just add your 0.6 each time. So 0.6 squared, 1.2 squared, 1.8 squared, 2.4 squared. 5 total pieces because we're adding up 5 rectangles. So I just want you guys to realize the only difference between these is one of them uses the first endpoint and one of them will use the last endpoint. One of them starts at the leftmost point, so it'll start at your starting point and it won't use the final one. The other one, you take off the starting point and you put in your last. That is the only difference when we're calculating these. Are there any questions there? Yeah.
This is a question of another comment here.
Uh-huh.
Will we have much work with
A calculator? You can use Desmos. Most of the stuff that we're going to be doing is just basic, like multiplying and adding things. So no complicated graphs. So if you have any basic calculator or just Desmos, something like that, where you can just plug in things and get an answer, you'll be fine. Does everyone have access to some type of calculator? Okay. Now I'm asking you to do the same thing with 10 rectangles. So how many pieces will I add up this time? 10. Okay. The width of them will change because my change in x, it's still a total length of 3, but now you're dividing it into 10 pieces. So that's going to be 3/10 or 0.3 for the change in x. Again, if you don't know for sure, just looking at it, which one's going to be your over and under estimate, you can always calculate the two of them, and the bigger one's the over and the smaller one's the under, if you didn't draw your picture. So for one of them, you will start at your leftmost point. We'll start at the 0. Would that be the over or the under in this case? The under. So my underestimate with 10 rectangles. This time my width is 3/10, and we are going to add up 10 pieces. So you will start at the 0, and you're plugging it into the equation, which was x squared, so 0 squared. Then you add your change in x each time. So 0.3 squared, 0.6 squared, 0.9 squared, 1.2 squared. Does everybody know where I'm getting these numbers? 1.5 squared, 1.8 squared, 2.1 squared, 2.4 squared, 2.7 squared. You only have 10 of them, so I have to stop here. Okay, and when I do that, we get 7.695. For my overestimate with the 10 rectangles, what's the only thing that will change? We don't have the 0, so we start at 0.3. And we have all the others, and where do we end? At 3. So if you type this in, you can hit second enter and bring it back, and then just change what you need. We need to drop the 0 squared and add a 3 squared to it. And we should get 10.395. You notice if you looked at with 5 rectangles, we had 11.88, 6.48. The true answer was somewhere in that window. When I went to 10 rectangles, my window got smaller. My underestimate got a little bigger, my overestimate got a little smaller, so now I know it's somewhere between these two. If you wanted to give me a good guess of the two, you could average them, add it up, divide by 2, and that would give you a ballpark figure, not exact, but it would give you a good idea of what the true area was. Questions on that? do some more. Okay, if I want the over and under estimate for this one, the equation is now 9 minus x squared, and I'm looking at the interval 1 to 3 using 8 rectangles. So we can draw a picture, but we don't have to. My change in x, how big is this interval? 2. You're just going to subtract those, and I want to divide that into 8 pieces. So that's 2 over 8, which is 0.25 or 1/4. So that is my change in x each time. Alright, so let's say you didn't draw a picture, so you're not for sure which one is the over and under. Let's just talk about how I would calculate the two of them. The width is going to be my 0.25, no matter what. How many things am I adding together? 8. One of them will start at your first endpoint. So the first one I will start at 1. Now I have to plug my 1 into this equation. So it's 9 minus 1 squared. Plus, you add your change in x. So now we're at 1.25. So 9 minus 1.25 squared. Plus, add my 0.25. So 1 minus 1.5 squared. 9 minus 1.75 squared. Do you guys know where I'm getting these numbers? And I need to do this until I have a total of 8 of them. So the last one I'm plugging in is 2.75. So now we go to our calculator. This is going to be a little more annoying to plug in. And you should have gotten 10.3125. When I do the next one, what is the only thing that will change? You don't include the first one, so your first point will be 9 minus 1.25 squared. And you will have all the others except you have to add in one more point at the end, so it would be 9 minus 3 squared. So if you type all this in, you can just hit second enter, bring it back, change your 9 minus 1 squared to a 9 minus 3 squared. should get 8.3125. So now it's obvious this is the overestimate, and that would be our underestimate. Questions here? Let's do one more. So for this one, what's my change in x going to be? 3 minus 0 over 6, so we get 0.5. So we'll be multiplying by 0.5 every time. The first one, you'll start by plugging in 0. So 13 minus 3 times 0, plus, then you just add 0.5 each time. So 13 minus 3 times 0.5, plus 13 minus 3 times 1, plus. We have 6 total. So it should stop here. If we plug those in, I get 27.75. For the second one, only thing that changes is you drop the 13 minus 3 times 0, so you start at the 3 times 0.5, and you'll have to add 0.5 one more time, so you'll end at 13 minus 3 times 3. So you can just hit second enter, change that 1 point, and you should get, what'd you guess? Yeah. So this first one was my over, and this is my under. You guys okay with this? Clearly this is not the best way to do it if you are going to have, 20 or 50 rectangles, because this will become very, very time consuming to write this all out. So we are going to get into some rules for adding things up. Today I just want to practice the notation. Tomorrow we'll actually start looking at the rules. Or you will be looking at them on your own, one or the other. So, the summation notation, it's the sigma. It just means you're going to add things. starting with 1 and ending at a particular number. So if I gave you this formula, it says you are going to add up from I equals 1 to 10 of I squared. So in other words, you are plugging these numbers in for I. So the first one you would plug in is 1 and you put it into the formula. So 1 squared plus 2 squared plus 3 squared. Where do we stop? Right. Okay, so if I asked you, this is what's called expanded notation. I just wrote out what it meant. And then if I actually wanted you to add that up, you could go to your calculator. And we get a sum of 385. So I put a few more on here, just practicing adding these things up. So the sum from 1 to 7 of k plus 1. So what would be the first number we actually add? 2. 2 plus 1, or 1 plus 1 is 2. Then you plug in a 2, which will give you a 3. Plug in a 3. What would be the last one? Right, because if you plug in a 7, 7 plus 1 is 8. So if you add those up, you get 35. B, sum from 1 to 6, so 2 to the end. So it's just 2 to the first plus 2 to the second, all the way up to 2 to the 6th. So you know, most of these things, we are going to get some shortcuts for these formulas, but on a test where you couldn't use a calculator, what I would want for your answer would be this expanded notation here. Can you show me what this means? Homework, when you have a calculator, you can go ahead and add them. Okay, C, this one is a little more interesting. I want the sum from j equals 1 to 5 of negative 1 to the j plus 1 power over j squared. So let's figure out what's going on. If I put in a 1, 1 plus 1 is 2. What happens if you take negative 1 and squared it? Positive 1. Over 1 squared is 1. If I plug in a 2, 2 plus 1 is 3. Negative 1 to the third is negative over 2 squared. If I put in a 3, 3 plus 1 is 4. Negative 1 to the fourth is positive over 3 squared. If I put in a 4, 4 plus 1 is 5, so negative 1 to the fifth is negative. If I put in a 5, negative 1 to the sixth is positive over 5 squared. So this expression is really just helping my signs alternate. It makes you go back and forth between a positive and a negative. And this time, if you put it in fraction form, 3019 over 3600. That's beautiful answer. I want to go ahead and do one more slide and then I'm stopping for today. So the next slide is just, I'm giving you the expanded form and I want you to write the formula that matches it. So first of all, you notice this goes back and forth from positive to negative. So what does it have to have? We've already seen something that would make it go back and forth from positive to negative is this type of pattern. Okay, so we know we are going to do the sum. You can pick whatever letter you want here. You can call it I, you can call it J, whatever. How many terms do we have? 6. So I'm going to start at 1 and end at 6. Now if I did -1 just to the I power, then when I put in a 1, would this give me a positive or a negative? -1 first is negative, but I want my first term to be positive, so I need to go ahead and do I plus 1 like we saw in the last problem because I want the first one to be a negative. And then 1, 2, 3, 4, 5, 6, those are just my i's, aren't they? So could I just say this times I? This will decide if it's positive or negative, and then 1, 2, 3, will just be your I term. B. Sum from I equals 1. How many total terms do we have here? 5. So sum from 1 to 5. Okay, these are all fractions except the first one. But 1, I could think of that as 1 over 1. So could I say all of these will be 1 over something? So keep in mind, this is first term is when I is 1, 2, 3, 4, 5. So look at how your denominators are related to your i's. What is it? I squared. Okay. One more. This one's a little ugly. Sum from I equals 1 to, how many terms do we have? 9. Okay, keep in mind your i's. This is when I is 1, 2, 3, 4, 5, 6, 7, 8, 9. What are these things? The square root of I. Square root of 1 is 1. Square root of 4 is 2. If you've reduced your square roots, you get that. Do you have questions? So we're going to go ahead and stop. Our assignment is a handout.